Hey, what is up guys? My name is Cherno and welcome to another episode of Game Programming episode 3 of season 2. So last time we were talking about how our server would be set up and how our multiplayer server, what kind of components it would contain, what methods it would contain, and how it would roughly function. And we ended up just creating a bunch of methods, talking about some Java programming styles and stuff like getters and setters and a lot of other, I will say, auxiliary kind of stuff. And today what we're going to do is just fill in the blanks for all these methods and actually create our server, right? So we're going to use Java's networking API to an extent here to actually create something that is capable of sending and receiving packets of data. First of all, I want to thank you guys all for the support. The Game Programming Season 2 has been doing really well in terms of views and interactions, so I'm glad that so many of you are enjoying it. That's really the most important thing here. Obviously, I don't want to be making videos that people don't really care about. So thank you for that. And I did just hit 50,000 subscribers. So that's also quite a considerable milestone, halfway to 100,000, which will be pretty cool. So, thanks for the support. Okay, so let's begin. The first thing I want to do here is talk a little bit about Java's networking API and what it consists of. What we're going to do to start off with is use a protocol called UDP, okay? And there are two kind of main networking protocols for sending packets over the internet, TCP and UDP, right? They differ quite a lot, but the thing to remember is that TCP really is something that is built on top of UDP, okay? These two specifications define a certain way of how bytes are to be sent over a stream, over a network. UDP is something that is quite a bare bones kind of raw way of doing things, and then TCP is something that builds off of that bare bones UDP thing and introduces some other factors that ensure primarily that packets are delivered and that the packet order is actually maintained. So if I send 5 packets over the network, TCP will essentially is a protocol, is a specification that will ensure that those 5 packets that I send will be received on the other end, and they will be received in order. Okay, that's the most important thing, right? Whereas with UDP, what happens is there is no kind of again UDP is the simple one, right? There is no guarantee of anything, right? What you do is you say to UDP, hey, I have an IP address and I have a port, I want to send data there. That's it. That's all you do with UDP, okay? That you basically just shove data to a specific destination. It's very much like mailing a letter in the sense that when you mail a letter, you just drop it off at the post office with an address and that's it, right? I mean, obviously, you know, in real life and with post, if the letter is undeliverable or something, it might get returned to the sender, or it might, you know, stuff like that might happen. Whereas with UDP, of course, that isn't the case, right? You literally just drop it off and you forget about it. Now, if you want to create mechanisms that do ensure that packets are delivered and they are delivered in order or other certain things, so basically if you do want to still have that functionality, you can actually implement that yourself. There is nothing stopping you from actually basically implementing TCP yourself on top of UDP, right? You can do that. I mean, I wouldn't recommend doing that because it's already been implemented and you might as well just use TCP if you're going for that route. However, that's just how I'm going to explain it, right? As in it's possible to do that because, you know, UDP is that kind of baseline where TCP is built from. That being said, games nowadays typically use a combination of the two. The reason TCP is a bit annoying, or the reason TCP isn't traditionally used that often in real-time gameplay is because when packets get dropped in a game, or when certain packets aren't delivered for whatever reason, could be a network issue, could just be the server not keeping up with the data flow or something like that. It's not really that big of a deal to actually care about the packets that didn't make it, right? As in, think of it this way: if you're trying to track someone's location in a GPS, and by the way, I'm coming up with all this stuff on the fly, so I hope it's acceptable. But if you're trying to track someone's location via GPS, right, and they're moving in a car, if you lose network connection for a little bit of time, right, you don't care about sending those coordinates of where they were while the network was out, if that makes sense, right? As in, I want to know what their location is now. If you drop a few frames, or if you drop a few packets, that's all right. Just don't worry about them. Just give me the most up-to-date one right now. That's all I care about. I want real-time information, right? Whereas if you were using TCP, then it would, during that network outage, it would keep resending those packets that never made it until they were acknowledged as being received. Okay, which means that you would get kind of stale data in the sense that you would get their GPS location from like, I don't know, 10 seconds ago, whenever the outage occurred, right? Whereas with UDP, you wouldn't. Why? Because those packets that didn't get delivered, who cares about them? I mean, I'm only sending the most up-to-date ones. I don't even know if they get delivered or not, right? Obviously, you can implement functionality where the client says, okay, server, I did in fact receive your packet, and we will be doing that to some extent ourselves. But again, that's up to you. That's completely up to you. So hopefully that example kind of clears things up a little bit about why, because in games, if you're reporting the position of a player, you don't care where they were 5 seconds ago if the network dropped out. I want to know where they are now. So once you restore the connection, don't worry about the old data. Give me the most up-to-date data. Okay, obviously there is still data, like if they picked up items or stuff like that, that is important, or if they tried to do damage. But if they're just movement data, coordinate data, give me the most up-to-date one, okay? I don't want to see them freeze a bit and then have a replay basically of how they moved to their current location. No. If the network disconnects, I want to see them freeze and then suddenly teleport to where they are now, right? Because I want the up-to-date data. Okay, so that's how it works, right? And then, of course, because of that, you might want to do fancy things like interpolation or other techniques to kind of minimize the visibility of packet loss and stuff like that. But we'll get to them later. That's the basic idea. However, TCP, why I say they're both used is because TCP kind of is also used for in games for things like, sending actual important data between server and client, right? Stuff like items and which level to load maybe, and more important things like chat messages and maybe downloading files, right? If the I don't know, you might have to download a map from the server or something. That stuff like FTP and stuff like that would definitely be done over TCP because you need to have the entire file. You can't just skip segments of the file, right? You need to have the entire file. I don't care how long it takes. You need the whole thing. It has to be 100% of it. So you do need to ensure that all packets arrive and in order. But for stuff like, moving and, don't worry about resending old stale data. I just want real-time data. For real-time data, we really do need to use UDP. So we're going to set this stuff up. I mean, we're not going to use TCP at all. We might use it later for chat because chat is something that I mean, if we were making a real-time kind of game chat here, and I mean just text messaging, then we would want to definitely run TCP. I mean, we've got two choices, right? We could either run TCP or we could write our own kind of UDP thing that ensures that everything is delivered. But we'll probably just end up using TCP so I can show you guys how they both work in Java. But with UDP, again, UDP is really simple. Right? Don't be overthinking UDP. UDP is a lot. There's no TCP has this thing called a three-way handshake at the beginning of its connection, right? Which establishes that connection and says, hey, I'm here, I'm the server, you're the client, are you there? Great, good, we can begin now, right? That's basically what it does. Because there is that initial kind of let's connect step. UDP, no, it's like the postal system, right? You just drop off your mail and you say, I want it to go there. That's it. That's it. It's out of my mind. It's been posted. That's what happens. So there is no establishing a connection. There's nothing like that. You just make a packet and you send it to your destination. That is it. Okay. So let's do that right now. The first thing we need to do is actually establish a socket, which our computer will use to send data over the network, right? Basically what this does is just ensures that we have basically, again, going with my postal system kind of analogy that I'm coming up with on the fly, that I'm sure people have used in the past a lot because it makes a lot of sense. We need to basically create a mailbox for our apartment building that says, hey, we're in an apartment building, which is our computer. I want to be able to send and receive mail, so I need to have a mailbox for that to happen. Otherwise, I mean, I have nowhere to, like, picture this as a mailbox where you also leave your mail, right? You don't, like, it's not like a post box where you kind of go out into the street, into some public area and you post it. You leave the mailbox in your, you put your mail in the mailbox, it gets taken, and then you receive mail into your mailbox and then you can take it, right? So to do that, we need to create what's called a datagram socket. Now the datagram part of it, use the datagram protocol, by the way, is what UDP stands for. The datagram part of it is the UDP part of it. That's why it's called datagram. And then socket is socket. I believe, I'm not actually too familiar with Java's TCP API, but I believe just socket would be a TCP socket. In fact, I'm sure we can check that right now. Why do I never have my source attached? If you guys don't know, by the way, if you guys see this, this is a quick tip. If you guys see this and you're not sure how to actually get the source code, all you have to do is click attach source, right? Go to external location path and then look for your JDK installation directory. Usually if you're running 64-bit Java, it'll just be C program files Java. It'll initially put you in the JRE. Get out of that, you want to go to the JDK, the Java development kit, and then you should see a zip file right in that directory called source src, right? And if you just open that, you will have the Java source code. So if we go back to socket, okay, so potentially it in fact is up to the implementation, right? So there's probably, I guess you can set up a socket that does either, right? So it's not decided by the actual class, it seems. I mean, a datagram socket definitely is a UDP socket though, as we'll see in a minute. So datagram socket for datagram packets, right? Which are UDP packets. Blah, blah, blah. Okay, cool. So anyway, the way that we run this is that we create a socket. This is what our server does at the beginning. We specify a port when we create the socket, so we do indeed want to actually, you know, when we start, we want to be creating that diagram socket on the specified port. What time am I at, by the way? 12 minutes. All right, cool. Still got a bit of time. I need to watch out because last video was like way too long. I know, and I'm sorry. This is going to be a try-catch thing, by the way. In fact, I'll let Eclipse write that for me. So socket equals new datagram socket, of course. When we start the actual server, we'll set up that socket. This is what we'll use for all incoming and outgoing connections. The port will be the port. And that's all we have to do, okay? Socket created. Again, that's us setting up our mailbox. Now that we've got the mailbox, we can send mail. So to do that, okay, so we set that up. We assume everything goes well. If it doesn't, then maybe we can, I mean, right now we're printing the stack trace, but we can probably return, we can probably handle that more gracefully by printing something else to the console, like, you know, port in use. I mean, this will do that anyway, but with the stack trace. So, and obviously we don't want to start the listening thread. I might just hit return or something here. And then there might be something, I believe socket might even have that, where there might be something called socket.active or socket running. I mean, I'm absolutely guessing here. Is closed, I guess, or is connected. Is this not the same as is closed? What does is closed do? So this returns connect state doesn't equal not connected. Sure. And then, this is why having the source code, by the way, is quite useful because you can actually see what it does. And is closed, or is that is closed? So closed is actually something completely different, it seems, than connected or not. Okay, interesting. But yeah, we might want to do something like, you know, I mean, in debug mode, we might want to assert, you know, between, like at send, for example, we might want to assert that the socket is connected, right? Or something like that. Just to kind of make sure that everything we do is actually, you know, just to help us with debugging in case this goes wrong. Because right now, obviously, we'll start it, we will see an error message, but it'll still attempt to send things, even though the socket isn't open. Or we, you know, a more kind of simple way of doing that would be, of course, creating a boolean called connected or something, or active. And then obviously, if this was successful, then we can set active to true. Otherwise, it'll be false by default and it will return, so it'll never set it to true. Something like that. Yeah, it doesn't have to be too complicated. But anyway, So let's cover sending. So we've opened up our mailbox. Now we can send mail. So sending mail is actually pretty easy because, as I said, there's actually nothing really here that we need to do except for just say that, we don't need to establish any kind of connection with our client or with our host, nothing. We set up our mailbox and then we just put a letter in there. So to do that, we basically just have to create something called a datagram packet. And a datagram packet is our letter, right? It's our piece of mail. So new datagram packet. Man, this mail analogy is really perfect. I'm really happy that I thought up that I came up with it right now, because honestly, like, a lot of these videos are just me. I don't have the time to actually kind of do pre-production on these, so I kind of just hit record and hope for the best. So sometimes my videos kind of go well, sometimes they don't though. So yeah. All right, so diagram packet takes up a few things. The one that we'll probably be using is this one, right? So we have a byte buffer, we have a length, we have an INET address, and we have a port, okay? And this is of course where picture this as, again, you're writing a letter, yeah? You have to specify the actual content of your message, right? So the actual letter. In this case, that would be the byte buffer and the length, right? So you specify, well, this is programming, this is computer science, so you actually have to specify how long, how much you want to send of that buffer. And then of course, at the front of the letter, you have to put in your address and your port, right? Which in this case is just your address. So we're basically sending this block of data. I'm going to assume that we're going to send the entirety of it. So I'm just going to say data.length. Again, just for future, you might want to break it up into smaller packets, maybe 4 kilobytes, maybe 1 kilobyte, something like that, up to you. And then of course you could do that by just checking to see how big that is first and then breaking it up into chunks before sending it. Totally acceptable. Right now we're going to assume that this isn't going to be too big. And I'm sure that this may break it up into smaller packets for you anyway. But again, the more packets you break up, the more packets can get lost, and you might have issues with that as well. So just something to keep in mind, that for larger sizes, I wouldn't be, because theoretically you could specify, a gigabyte of data here, but clearly that's not going to be able to get sent as a single packet. So you might have to do stuff to break that down, which you could do client side or you could manually do inside here because you know how big it is anyway. So we have the length. We also need the INET address. So when we send something, typically a good idea with that is to actually have a place to send it to. So I'm going to create at least one version of send here that takes in an INET address and a port. Okay. And then of course, in this case, we just add an address and port here, and that's it. Our packet has been created. And then finally, what do we do when we want to send that packet, which is our letter? We put the letter in the mailbox. So we say mailbox or socket dot send packet. And that's it. That is how you send a UDP packet over the network in Java. It is extremely simple, very straightforward, because again, it is straightforward, right? There's no guarantee, there's nothing you need to set up. You just drop your letter in there and off it goes, hopefully. Might not, but that's the risk you take with the postal system that is common, modern networking, I guess. Okay, cool. So there we have that. One thing I will note as well is that as far as these things go, if we jump over into our server, yes, here, if we were to send something, I mean, right now we do need to specify the data, the address, and the port. As far as addresses go, there are a few ways to get that. I believe there's something called address, let's see, get by name. Okay, so this will potentially, there's something that will create an INET address for you from a string. It might be this one, but that doesn't look like it because that looks like, interesting. I'm not 100% sure how that is supposed to work exactly. But yeah, there should be something that just lets you specify a string. I'm just not sure where it is in the API, where it lets you specify a string, and then you can basically just end up sending something to that address. Maybe it is get by name. Get by name. I think it is that. So for example, if I was sending something to my local IP, like to a server on my local network, and the address of that server happened to be, I don't know, that, right? I would create that. I would create my port for that server, which, you know, as we all know, is going to be 8192, obviously. I mean, in this case, you know, we are the server, so pretend that this is the client, I guess. I've got a client on this IP address. I've got my port, which might be the client's port, which could also be 8192, whatever. And then I have my, you know, I might be sending a few bytes of data. So we'll say something like, you know, 012, right? We've got 3 bytes of data there. We've got an address we're sending it to, which is this. So we'll say address, and then we have a port. All right. Now, unfortunately, this, as you know, Java likes doing, will throw an exception if it doesn't work. I hate it when, I just hate the whole exception situation. I just don't like exceptions. But anyway, all that aside. So basically, if it can't decrypt this, like if we were to write something ridiculous here like that, or if I was just gonna, you know, write something like Cherno and then it couldn't, you know, use DNS to resolve that or something, then it would tell me that it doesn't know what the host is, and it would return that. Okay, our local host, of course, will be 127.0.0.1, otherwise known as localhost. That's, you know, what this IP address would be. So if I had both the server and the client on a single IP address, they would need 2 separate ports, of course. However, the IP address would just be that. So this is an example of where this is actually a different machine, a different computer on the network, acting as the client/server. Okay, so there we have it, a full example of how to send something. This will actually send the packet, okay? If I run this right now, you can see that I don't actually get any errors. Now, I don't know if it actually sent that or not, because we have that listen thread. I assume it did. I mean, one way we could check is we could put a breakpoint in here. Okay, cool. So it looks like it does. So it sends it, everything's fine, no exceptions, exits, okay? And of course our application here keeps running because we're still running that listener thread. But that is how that works, okay? So we just successfully sent 2 3-byte packets to a IP address that probably might be my printer, which is off currently. So pretty cool, right? Great, that's gonna wrap up this video. Hope you guys enjoyed watching. As always, don't forget that you can obtain all the source code for these videos by simply going to, well, you're gonna have to, first of all, go to patreon.com/the Cherno, link is in the description, and pledge at least $5 per month, and then you have access to all of that. You basically have access to a private GitHub repository, which looks like this, and contains all of the code for each episode, okay? So this will both contain the entire code for just Rain in general, right? So all the code that I've ever written for this game, including all the graphics and all 126 episodes of the game programming series, all the code is absolutely here on GitHub, available for you to grab if you are so inclined. Also, it helps to support the series and make sure that I can keep pumping these videos out every week, as I am currently doing. So of course, your support there is greatly appreciated and keeps the show going. Otherwise, of course, feel free to hit the like button if you guys enjoyed this video. Leave your thoughts in the comments below. Next time, we're going to take a look at how we can receive packets of data. Yeah, and we'll kind of keep this ball rolling. So yeah, I'll see you guys next time. Thanks for watching. Goodbye.
Vroom.